you very much for this opportunity. I would like to very thanks with
Signet, Bruce Mason, hold that microphone closer, please. We're having difficulty.
Wonderful.
Okay.
Thank you.
Okay. Yeah, I hope this is the better. I would like thanks to our colleagues from ERI, Bruce, and your colleagues is already arranged for this discussion, and my colleagues from BMKG, from Pusgen, in here already attending for special from Mr. Masur Isam and then Prof. Joyo. Thank you very much already attending and support us. And I would like to present about the insight of the ground motion from Cianjur earthquake. And this I want to present particularly about the characteristic of the ground motion. So Bu Rahma Hanifah has already described about the all the scope of the environment, and then the distribution and the damage, and then what he see done with her team. But now we will present about the monitoring accelerometer from BMKG, and we will start with the this information of the distribution of the earthquake source in Indonesia, and this is already presented by Bu Rahma before, and this will concern with the location in western of Java Island, and then this is the western of Indonesian part time, and in here this will already accounted by team from Pusgen and already updated 2017 and SNA 2019. And for this case, for this earthquake is very interesting, because this is hazard not mapped for this hazard map in Indonesia. And I think after this case occurrence of the earthquake in Cianjur, we will complete with the, I will edit from the new location, but this is the still part of the big Cimandiri port system in the western of the Java. But this the segment is very important to give the lesson learned for the next, because this is the very severe damage found by the team when we survey directly when after the Cianjur earthquake. And this is the sequence in the last decade on 10 years ago about the last damage earthquake, the destruction earthquake. So until the impact, the seriously of damage, and then the causalties we found impact of the earthquake. So this is the start from the Lombok earthquake with the magnitude foreshock 6.4, and then the mine shock 6.8, and then will be followed by the Palu earthquake with a magnitude 7.4, and then the Ambon earthquake, the magnitude in the eastern of Indonesia, and then this is the recently the Somlaki earthquake, magnitude 7.9, but there is not many damage for this earthquake. And then the western of Indonesia is any Tarutung earthquake, and then Mentawai earthquake, and then in the mid or the Java Island, this is close to the Cianjur earthquake, in the eastern part of the Cianjur earthquake. Before this, and in the Malang earthquake with magnitude 6.1, and then the magnitude 5.6. So this the sequence, the earthquake before the Cianjur earthquake in last 10 years ago have the big impact with the building collapse, and then the causalties after the earthquake, after the occurrence of the earthquake. And we more detail with the scope in the close to Cianjur earthquake. So we take from the our catalog in BMKG. So we already found any the 6 earthquake in the surrounding of the Cimandiri fault system. There is any significant before the Cianjur earthquake in here in 2020. So in the western part, Cianjur earthquake is already occurred of the earthquake with magnitude more than 4. Then this is the distribution after our team survey in the file survey. In here we make the classification with regarding with the MME level here. Is we regard from the earthquake parameter from National Center earthquake of the BMKG. This the focal mechanism type is the stress slip fault, and then we found many damage. The distribution I think is not very significant because it's the classified not very strong until the severe damage. This is the close from close to epicenter, and then we have tried to mapping for the classified regarding of the MMA. So we have looked in here. So this many damage of the distribution until the severe. This is the clear in the surrounding of the epicenter. And this is, I think, this is the my focus to discuss this at this moment for with all the participants in here. So about the ground motion recorded from from BMKG's monitoring from the accelerometer, and we already collected from the 5 sensor in here. So in eastern or southeast from the epicenter, and then the western of epicenter, there is any KCGR and then LTGR and STDM. And the western part we found the DSTR and SSTM. This is about the value in here. We can could you see in the right side the figure in the right side, the strong motion data cianjur earthquake. So from the KGDR, this is the maximum PGA value. This is the maximum from the component. Does not use geometric mean before. I hasn't used yet for geometric mean, but we selected already for the maximum each of the component. And then the LCDR, the second one, SCDM 264, and then the 194 from LCDR, and then DSCR in western and SDM in western part of the center. But actually, for we can see in here from the western of the epicenter, the distance this far away from the epicenter, but the close from the epicenter on the near source, we can specific see in here from for the station KGDR, LTDR, and STDM. After we see about the location and then the PGA value, so we can see in here the characteristic of the anatomy of the waveform. This we can see this very clear from the STGM in here. This and in the long period. So we can see in here for the STGM after a few seconds arrive of the detected of the event PWF. So this we found this the long period characteristic from the STGM. And then this is the not similar with the LTDR. LTDR is the close to STGM, but this is the high frequency. So not clear about the long period, but it's all the short period or on the high frequency. The KGTR is very unique in here. Why I say this is very unique because this is the different each other. in KGDR, this is the highest the PTA value until 501 gals in here, or 0.5 D. But this is the when we see the peak, this is the only one peak. This is the different with the others, the sensor. The other sensor like LDDR or SDGM or the SDR or SSDM, this is any one cyclic. So this is the recycling of the amplitude, hike the amplitude. But in the KGDR, this is the only one. Only one that's the very high, and this is the highest of the amplitude. So this is the highest PTA value. But there is the difference with the other component. This is the east-west component until until 500. But for the not short component, this is 200 until 300, 200 more. But so this is the very any the inputs the very significant strengthen of the motion when the cianjur earthquake for the KGDR waveform from the accelerometer recording. But for the SDR and then the SSDM, this is the long period as well, like SDTM, but this is still any the high frequency for the SSTM and then the SDR. This is the very different with the SSTM because the very clear from STDM, the previous mentioned, this is the long period detected after the few seconds after arrival PUF in STDM. And then this is how we compute for this ground motion here. So this highest value of the PDA and then the cyclic motion of the ground motion accepted for the KGDR, and then the KGDR only one peak highest peak until the 500 gal. So this is the different and unique than others accelerometer recorded like the DZT, SDR or SDGM. And this the more detail we will compare between the KTDR and then the LTDR. So this the very clear for the KTDR for the east-west. This is the only one peak until the 100. But the LTDR, this is cyclic with the amplitude after decrease. This the increase again in the next time in the few seconds after the maximum amplitude in LTDR. This is similar with the other except for the KTDR. And this is the frequency domain, or the this is the very clear as well for the distribution of the frequency in here. For the KTDR, this is the only focus in 20 until 25. The maximum approximately in 25 Hz. And then for the LTDR, this is the many frequency on the maximum peak is almost similar in the several frequency, not only one frequency. We have a look in here maybe like in the 20 maybe 27 or 26, and then the more 30, 35, this is amplitude hike again, and then more than 40 Hz, this is hike again. So this is the weight of the frequency, the large the frequency is wider than KGDR station. So this representation of the energy is very various in the LTDR, but in the KGDR station, this the dominant with the energy frequency for the high frequency in frequency 25 Hz. And about the spectral period between the all the station, the SDR and blue line, SDM or green line, KGDR in red line, and LTDR yellow line, and then the last for the SCGM. So we can see in the SCGM here. So This the response period is in the long period. This is the associated with the background of the SCGM. Probably this is the thick of the sediment in that location. But this is very different with the LCGR and then the KTGR and then the yellow as STM. This is the response for the period in the short period. So approximately in 0.1 or 0.2 for the maximum spectral acceleration maximum for that station. And here we note there's the two station. This for the STGM, there's the longest period, and then the SGR, this long period, but this is significant different. But actually for the short period is very clear from KCGR and LCGR. This is, I think, related with the condition of the background of the topographic. In here we can see this and in the different type of location. And this the acceleration direction between two component. For example, the first the east-west to north-south, but this is still any associated with the maximum. So we in here like in the left side left figure, the top left figure in here, you can see 500. So this is the representation of the east-west motion from the KJJR station in Pasir Kelapa location. And then the north-south to vertical component, this we can see this the pattern of the particular direction in here, and then the east-west to vertical component you can see in here as well. So there's the dominant to east-west. So for the maximum direction amplitude in here until 500 from KJJR station. And regarding from the hazard map in Indonesia, this updated the hazard map SNI 2019 from Pusgen, as we can tag in here the location for the source of the cianjur earthquake, and then surrounding this we can see the PGF value, the maximum on the hazard map is until the 0.5 until the 0.6. So if we make the correlation to the accelerometer recorded from the one station KCJN, so this is already reached for this worst descent in Cianjur location by the occurrence of the Cianjur earthquake. So this I think this this the very realize this impact is destruction or damage is very seriously. But this is still many questions why with the already only with the magnitude 5.6, not more than magnitude 6 usually for the fault, and for example maybe 6.5 or more, but this is only the 5.6 magnitude. So this is the already reached until the hazard map calculation for Cianjur location. And we compare with the design from the area from the hazard map SNI 2019, and then the strong motion recorded from KJJR station. And here, beside for the PGF value, we can see in here for the short period, this already accidents for the design. So this is the very high. This I think not only the outset of the BMKG College acts about this, but internally we already discussed and there's many questions in ourselves. So, but this is actually this is the recorded, and when and actual, and then this is the fact, and we already discussed as well with the Japanese colleague, because this is the instrument, this is the fund from the Japanese, and we collaborate to process this waveform, and all our colleagues, and then we discussed as well with our colleague from ITB, maybe Mr. Masyur Isam, and then from Universitas Indonesia, Prof. This we found this is the actual that we cannot we until now we hasn't found is there any reason to ignore this signal for this waveform, because this is very clear, and this is I think this the big message for us. This is the any actual with the magnitude 5.6 can produce until the response of the spectral like this, and the more the descent calculated from the sort of the fall. And when we compare with the GMPE, from the NGA, we selected for the board at Kenshin and Chaoyong and Chaoyong 2008, 2014, for at all 2014, and Zhou 2006. But in KGG Air Station, this is higher than all the model of the GMPA from the NGA. So this, I think, this the question mark for us before, but this is the actual. So we're from the distance only less than 20 kilometers could be produced of the height of the PGA value. This is the until 500 gals from the accelerometer recorded from cianjur earthquake. And this is the before us distribution of the our team after first survey. I think this is similar with Bu Rahma Hanifa mentioned about her result first survey team in cianjur earthquake. This is the ground failure, and then the totally collapse, and then we can found this and in the structure buildings collapse as well, and then facilities like the government office, the old buildings, not until the totally collapse, but for the some part of the building there's any crack, and then in the other areas in the close to epicenter, we can find like the landslide, and then the structural collapse as well, like in M point in here, and then landslide too, and then any the road, this the move to the different direction. This is the location the close to epicenter. We already found that. And this is our team when we support to our data from field survey, and we already visit to location in the day earthquake, and then we did the many type survey. This is the microseismic survey, and then the MISW survey, and then the TDOM survey, and then we air survey using the drone, and then we use the geolistic method to analyze the subsurface like MISW, and then the mapping of the distribution of the destruction or the damage by the cianjur earthquake. So I think that's all our presentation, and thank you very much.
Thank you so much, Signet. I was fascinated by your discussion of your time history and response spectra. I may have questions on them, but first, we need to get the audience's questions in. So I'll turn control over to Volkan, and he will have questions for our speakers. Volkan, can you please proceed?
Thank you, Bruce. Thank you, Sigit and Rama. We get a lot of questions about, first of all, great presentations, and you have done a lot of work, and you really went into deep details of the relatively mid-sized earthquake for Indonesia, and looks like there's a lot of important data coming from. I'm a little puzzled by the half a G acceleration with that particular station, which is, I think, around 500 gal, around 10 kilometers from the epicenter. Did we have any site amplification data that you can obtain, like VS30 and others? The location looks like it's in the boundary of a mountain and perhaps a basin. So sometimes those interfaces could amplify shaking as well. Are there any like a control set to make sure that that particular data is not somewhat biased of a single location?
Okay, Volkan. About the support of the MISW survey, we already done from the all station, except for the DSGR station. For the DSGR station, we have the MISW.
Signet, please talk into your microphone.
Yeah, sorry, I forget. Volkan, we already done for this MISW survey, and we have looked the result in here. So the average for the VS30 is the around the 250 meter per second, or the classified D. Classified D. So this is the
very high amplifying.
Yes,
very high amplifying.
It's already done. Yeah.
Okay, this is very interesting.
Okay, thank you.
All right, Bruce, would you like to ask a few locations?
Yes, I would be more. I have plenty of questions. The question, and this would be for either of our speakers today. Can you explain why the damage was so widespread? Our understanding is for a magnitude that size, we wouldn't expect to see such widespread damage. Is this because there was landslides or some other phenomena? And again, just in a few sentences, a general reason why the damage seemed to be so widespread.
Okay, thank you, Bruce. Personally, this is the my opinion for this, because this is the our question as well. When we found this, actually in the surrounding of the Cianjur, so there's the many damage in here. So we try to this, I think this is correlated with the potential of the thickness of the sediment in that area, Bruce, because this is the close to the volcanic. This is the Gunung Gede, Gunung Gede. This is the very close, and I think this contributed from the thickness of the sediment in that area to make the amplification motion. Besides, this is the area, this is the very close from the epicenter, but there is any contribute of the condition of the soil, medium soil, subsurface in like in the Cugenang and then in the Sarampat location, because it is that area is the very significant distraction.
Okay, great. So am I correct to understand you're saying because of the volcanic nature of many of your soils could have caused amplification? Is that is that one of your points? Okay, very good.
Yes.
Another question I have is this. With regard to
sorry, Bu Rahma, maybe any opinion maybe?
Yeah.
Okay. Okay, I have another question, and then maybe Volkan has more. It has to do with the type of construction. It seems to me in your country, you have so many frequent earthquakes, and is there incentives to build primarily out of wood? Wood we find to be much more resilient. The damage you showed, as I gather, a lot of it seemed to be unreinforced masonry type construction. Is there incentives? I mean, just from experience, we see so much damage that maybe there would be incentives for people to build with wood, just out of wood or bamboo, which would be a lot better. Could you comment on that? Rama, perhaps.
Yes, thank you. So, yeah, I think as Pasigit already mentioned, it's because of the volcanic layer and also because it is a shallow earthquake happening in the dense populated area. And you see that it's correct that many damage is from the unreinforced concrete masonry. And many of the wooden structure, wooden houses actually still standing. But currently in Indonesia, we have a major shift, like many people prefer to build from masonry type, even though it is unreinforced. And sometimes building from wood in the good quality of wood can be more expensive than building concrete unreinforced concrete masonry. But yeah, I think it's also something that we need to work more on. So the government already prepare building codes, earthquake resistant building codes, and also there are guidelines to build the house resistant house construction. But for the implementation, sometimes is limited due to the economical factor. Actually, here we have an expert of civil engineers, Dr. Haris Mulyo Pradono. I don't know if he want to provide also some explanation on your questions about the housing.
Well,
Thank you.
if you could join, that's fine. But if not, Volkan, do you have other questions?
No, actually, I have. Maybe you can go ahead and.
Okay, excellent. Well, with regard to, I know, Signet, you talk much about this KCJR record or acceleration record. It seems to me that was on a rock site. The application was at a very high frequency. Is that correct?
Actually, this is not a rock site. But
it's not a rock site. Okay, that's surprising.
Yeah, but this because we found it and after we
please speak in the mic.
Yeah, after we got the survey from the SW, so we found this average for the first 30 only the 250 approximately 250 meter per second. So is the classified from the stiffness classification, so not outcrop or not rock. But this is still our team the question mark for this value. But actually from the waveform we cannot debate for this waveform because actually this on the procedure from the background noise when the earthquake occur, and then how the step of the processing and then the quality data before the processing we already done, and we will collaborate as well with the comparison with our colleagues from the board. This they already similar with the result of the PGA value. So I think this we will publish. We already published for the value until 500.
Okay.
But I'm personally I'm very interested with the not only a CEO from the PGA in the value, but the characteristic the ground motion. So this the only one peak. So this not cyclic like in Palu or like in other sensor surrounding of the epicenter location for the Cianjur earthquake. This the location. This the only one peak, and but this is very high.
Yeah.
This is the any that's the characteristic. I think this is the any something for this the type like in the KCR station from the waveform.
Okay.
Thank you.
Thank you so much. We're near the end of our time. Volkan, do you have any other questions?
Yes, one last question. Maybe we can ask Rama. what are the plans for more seismic resistant building plans for the Indonesia as a whole? Do you guys have any new building code updates coming up?
Thank you. So for the building codes, the latest building codes is in 2019. And usually after we update the new hazard map, the building code will be also updated. So basically the building codes, especially built by the Ministry of Public Work and Housing, is following the latest building codes. But we still have a lot of problem with the, especially with the housings and with the contractors or other parties that are not following the building code. So there are no strict implementation or punishment if people are not implementing the building codes. So I think it's also something that we need to work more on, like ensuring more implementation to building codes. The guidelines and the building codes are already in place and updated in the regular time, but the implementation maybe need to be more work on the implementation.
Thank you so much. Before we go away, I would like everybody to look at the chat, because Rama graciously provided links for the data for this event if you like to use it, because at the end of the session that chat will disappear and you won't be able to get it unless you email them. So for the final remarks, maybe I should start with Bruce and then Elizabeth.
Okay, I would like to thank both of our speakers today for giving us very informative and enjoyable presentations. I know I learned a lot. I would like now to turn control over to Elizabeth for some closing remarks. Elizabeth, please proceed.
Thank you for joining us for today's webinar. When the webinar ends, a survey link will pop up in your browser that contains a post-webinar survey. We'd be grateful to get your feedback on this event and suggestions for future topics you'd be interested in hearing about. If you don't have a chance to finish that now, you should also receive that via email. So please take some time to fill that out if you can. You can learn more about ERI and how to join at our website. You can find out about upcoming webinars and events in our Pulse newsletter. And then finally, I just wanted to say that webinars like these are supported with funding both from FEMA and by ERI members like yourselves. So thank you for helping make events like this possible.